Hey, this is Don from Padlock Technologies again with another video. We talked about transparent firewalls and inline sets in a last video that I just did on ASA clustering. So today we're actually going to go over the theory, and then the next video I'm going to actually show you what inline sets look like. They pretty much do the same thing as a transparent firewall from a functionality standpoint, but it's running in routed mode compared to transparent mode. So what is transparent mode firewalls? So it's very simple, bump in the wire, right? So this makes the firewall basically look like a bump in the wire. So let's get down to the blackboard here, and we'll just say transparent firewall, right? So you have your traditional firewall. Everybody knows traditionally a firewall is L3, right? Now with the transparent firewall, it's L2, right? Now there's a different setup on an ASA versus an FTD, and we're going to go into that right now. So on an ASA, we'll just use red for ASA right now. So we have the ASA here, and I'll just say TFW ASA. You will have it's sitting in the wire here. So this right here is the same subnet, same sub. Now, in the ASA, it's a little bit different from a setup perspective because you have these things called bridge groups. Now, you can still do bridge groups in an FTD, but the way that the FTD does the transparent firewall or, inline set, you really don't need the bridge group anymore. On the ASA, you do need to have the bridge group. And the bridge group is going to be applied here and here. When you add these two interfaces to the same bridge group, this is where the transparent firewalling comes to. So you have a bridge group here, right? You can give it whatever number. Let's say it's bridge group 1. So now that ties it together. And then you have another piece that's called the BVI. So the BVI is the bridge virtual interface, bridge virtual interface. Now you need to have this bridge virtual interface up and running before the actual bridge group or the transparent firewall capabilities will work. Now this is going to have some kind of IP address, so x.x.x.x, and this is how you're going to communicate with the firewall. You can actually get to the firewall using the BVI, but you need it to actually do the bridging together. Now, the key thing about this here is you still need security. You'll still need your zones, right? You'll still need your security levels and your zones. So that doesn't go away. So here you would say this can be outside, and then this could be inside. Now you're not going to have anything from a NAT perspective here, but when you apply your policy, it still has the same security zones in it. So from an ASA perspective, outside is always anything that's not inside is automatically given a security level of 0. So you can call it whatever you want. If it's not specifically called outside or inside, it will always have the security level of 0. So the SL here is going to be 0. Since it's inside, the SL is going to be 100 by default. And if you know how ASAs flow, by default, higher levels can go into lower levels, but you need an access list to go from a lower level into a higher level. So where would you apply in this design? Where would you apply your access list? You would apply it. I'm running out of colors here. You would apply it here. So here's where the ACL would be applied, right? Now, for simplicity's sake, we would have a permit IP any, but transfers firewalls also introduce ether type ACLs. Now, ether type ACLs is where you can match things like this. So we can match on this. You need to know your ether types. Okay, for you guys that are studying for your CCNP, CCIEs, CCNAs. Well, not CCNA so much, but you need to know your ether types, right? You need to know what the ether type for IP is. You need to know what the ether type for MPLS is. I believe MPLS, if I'm not mistaken, I think I don't have enough zeros here, but I think MPLS is 8448. Right? I think that's MPLS. Do not quote me on that because Even though I'm a double CCIE, very rarely did I have to do an ether type ACL. So don't kill me in the comments if I get these ether types wrong, but doing this for over 2 decades, sometimes things slip out of your brain. But once you have the transparent firewall on the ASA set up, now transparent are unbeknown to the people in the middle. They don't know the firewall is there, right? Now, in this day and age, a ASA in transparent mode is pretty much useless at this point. And why do I say that? Because with all these next generation attacks and things that are happening, there is no level, and let me put this without the SR module, by the way, there is no layer 4 to 7 inspection here. So that is just not there. So at this point, there's really no point of putting that there, because you're just going to get 1, 2, 3, and then when layer. Now you can do some layer 4 stuff, but you're going to have to mess with. I really don't want to tell you to do this because I don't want somebody to actually do this, but you'd have to mess with MQC and MQF. So modular queuing framework, modular queuing command line, which is basically used for QoS, but you're going to use it for security purposes. It's the same thing like if you're doing a zone-based firewall, you would do MQF or MQC, but you're going to do different policy. You're going to do different types for zone-based firewalls. We're talking about the expect. So you're going to use class map inspect and policy map inspect. For you guys that are going for your CCIE security, you better know that. Just chances are you're going to have to do zone-based firewall, which is a very old technique that you're doing firewall and routing. But another side quest, let's get back to what we were talking about here. So on FTDs now, same concept, but now you have two different options. You can do transparent firewall, which is pretty much the same here, but now you have the layer 4 through 7 capabilities, because you can still add your IPS and your malware, but you also have this thing called a inline set. And that's what I'm going to focus on here, because if I showed you transparent firewall on the ASA, it's literally the same concept on a FTD with a little caveat. So let me explain the caveats here. We'll just do a blue FTD. So we still have bump in the wire here. Now, the thing here is we no longer have bridge groups. You don't need a bridge group for transparent firewalls, right? You don't even need the BVI. Why do you not need the BVI? Because you have a dedicated management interface that you can get to. So dedicated management, so you no longer need the BVI here, right? But you still have transparent policies, right? So you'll still have your zones now, because you don't have security levels anymore on an FTD on FTDs that no longer exist. You have zones, so you still have to create your zones and all that good stuff, and then have your policies or your ACPs and ACE entries that allow stuff in and out. Same concept. Now, what is inline sets? Like I said before, how I hinted before, it's virtual wires and another vendor called Palo Alto. They use this thing called virtual wire. I think Fortinet does virtual wires, literally the name virtual wire as well. On an FTD, it's called an inline set. So it's the same function, but the difference is, so we're going to draw another FTD right here. FTD. The difference is I can have a routed interface here. So this is routed interface. And then I can have an inline set here. So inline set, and we put routed here as well. So the difference here, and the key to utilizing this, and why I would say people should use this method over your traditional, and I'm going to say this is traditional here, transparent firewall. The reason why people should go into inline sets, because it allows you to have the layer 2 bump in the wire functionality here. So this is layer 2 R3. Now, when I say layer 2 R3, you can send IP traffic, or, you can technically have spanning tree go through this too, but you can have your bump in the wire. Let's say bump in the wire. You still have your bump in the wire enforcement and wire enforcement. So transparent to the user. And now you get the added benefit of, let's use green, of layer 3 enforcement. So you can still route traffic like a normal firewall and not have to. The thing here is when you go from a routed firewall to a transparent firewall, you blow out all the configurations. And if you go from a transparent firewall to a routed firewall, you blow out all the configurations. This marries both worlds, right? So you can have layer 2 enforcement and layer 3 enforcement on the same box without having to blow out the configs, right? Now, you do have this thing called an inline set. You're going to have certain zones for inline, right? Because you have your normal layer 3 zones and then you have your inline zones, right? So this would be, and I think in the lab, I called this one inline set outside, and I called this one inline set inside. And you still have to have policy based on this, right? So you still have to have that stuff in there. But now, again, and this is a question I usually used to ask in interviews, like what's the difference between ASA and FTDs from a traffic enforcement standpoint? There's no such thing as security levels anymore. Everything is equal at this point until you add policy to it. So again, ASAs, you can just give it a security level higher than the level that you don't want it to, that you wanted to go into by default, and that traffic would flow until you put an ACL on the inside interface. Let's say inside outside. Inside can flow to outside, no problem. Outside can't flow to inside without an ACL. But if you put an ACL on the inside interface, now the inside ACL dictates what goes through. Right. So that was a trick question I used to ask a lot of people when I was hiring for security people. So back to the inline set. Inline set kind of functions the same way in terms of, hey, we still need, it functions the same way as layer 3. So in the layer 3 environment, you put your interfaces in zones, and then you would have your policies based on that. Inline set, same thing. You put those interfaces in zones, and then you would have your security policy based on that, right? Now you can still have traffic go through there. But again, it's all going to be a bump in the wire. It's going to be transparent to users. So you can have, same subnet on each side, but you're having inspection going through there, and then you can have your malware and IPS policy inspect the traffic. Again, though, this is not SSL decryption, so if that traffic was behind an SSL tunnel, you couldn't technically decrypt it because you're running it at a layer 2, right? Now, if you're doing a layer 3, which I showed you guys already, you can do your encryption, and then when you do your decryption, you can see everything going through it, and you can apply your malware and IPS policy. So this is the difference between transparent firewall on an ASA and transparent firewall on an FTD and inline sets, right? You have 2 options on an FTD compared to 1 option on an ASA. Hopefully that answers that question. This is Don from Padlock Technologies. I hope this video was informative. Don't forget to share, comment, like, and subscribe. Keep hitting me with the questions because, again, you guys are keeping my brain active. And I like giving up my years and decades of experience for the next generation of engineers to come up. I know it's hard. You guys are looking for resources to give you some knowledge. So that's what I'm here to do. Thank you. Have a nice day.